I can start. Cool. Hi, everyone. Welcome to this session on Serverless DX done right. So how many of you are currently working on a serverless workload on AWS? OK, a few of you. So what I want to share with you is one part that I have seen quite a few customers struggling with, and trying to show you one simple thing. When I was a developer, back in the days, as you can see, I'm not as young as many of you. One thing I was doing in the morning was waking up, opening Eclipse, and then staying with Eclipse for more or less the entire 8 hours of my work, and time to time looking at the browser what I need to discover. And that's something that, honestly, is I think developers love that. Sometimes it's not an IDE anymore or an editor. Maybe it's staying with the terminal. It depends what is your style. But what I want to show you today is how you can do that working on a serverless application using Lambda functions and API gateway and a few other things. Who am I? My name is Luca. I'm a serverless developer specialist. Serverless specialist that is working in AWS, coming from London, but as my name suggests, I'm Italian. OK, so this is enough for the introduction. For me, a developer experience session should be done live with the IDE, and that's it. So that's what we're going to do today. If it works. It doesn't work this way. I don't know if I can do it again. Choose content. Entire screen. Start mirroring. Does it work? I'm showing another thing here. So it's extended.
Do you have it in PowerPoint or?
Should I close PowerPoint because it doesn't like it? OK, works. Perfect. So PowerPoint. Amazing. So is it big enough at the bottom? Can you see that? OK, cool. So in a few months ago, before reInvent, that is our main conference in Las Vegas, we launched a new wizard that if you are not familiar with serverless and you want to learn how to build an application using serverless, we have like a step-by-step guide that you can have and you can install easily in your IDE. So the tool that you need to install is called AWS Toolkit. AWS Toolkit is a plugin that is available for VS Code as well as for JetBrains IDEs. And the beauty of that is that allows you to have this experience here. So the first thing that I ask you when you want to create an application using serverless is to install a bunch of things. So the AWS CLI, this is a quite common tool that you have installed when you are building software in AWS. SAM CLI, that is a serverless application model, that is one of our, let's say, tool for creating infrastructure as code that it can be used, or you can use Terraform, whatever, but it's useful also for testing locally. So SAM is a CLI that enables you to not only create infrastructure as code, but also testing locally your Lambda function, API gateway. You can use also with step function and DynamoDB. So quite a versatile tool. And then obviously you can install Docker, but the interesting part starts on the second step. So in the second step, you can initialize a project. So we have received a lot of feedback from customers that they don't know where to start. And therefore, we created this experience where you can select a bunch of common, let's say, pattern like REST API, file processing. If you go at the bottom, there is See More application example. So when I click here, it takes a few seconds, because what it's doing is basically loading remotely a bunch of a repository on GitHub that is completely open source, so you can check what the code looks like, and you can select your favorite Lambda runtime, and from there, basically, you can decide what you're going to build. So you can package your Lambda function as a zip file, or you can package as a container image, so OCI. So either case, you can use whatever runtime is supported by us, or you can create a custom runtime as you prefer. The cool thing of this is that you don't have to start every time, oh, I need to create this file, that file. You have like a shortcut or a blueprint for starting. But there is a third thing that we, let's say, integrated inside this system. That is this visual builder. Now, you cannot see very well because it's here at the bottom, because I have like the screen that is magnified quite a lot. But when I select this and say initialize project, it's asking me where I want to start. So I have like an empty folder that is this demo init, that basically didn't have any file. But now, as you can see, there is a file called template YAML that was created by the infrastructure composer straight out the moment that I click into that. So this one is something that you can find also in the console, but it's very comfortable having it on the IDE. The cool thing of this is that basically you have all the AWS resources, not only serverless, so whatever it is. And if, for instance, you want to create a quick API that is needed with a specific tool or specific service that you have in mind, you just simply drag and drop it. For instance, we want an API gateway and the Lambda function. Then you connect it. So now we have a connected Lambda function with API gateway. We rearrange and we just see what we have built. So this is what we have built. We have an API gateway with a Lambda function. If I select this, I have a bunch of capabilities related to the service. So very often, you know, when you have Lambda function, it will set up the memory, the name, if the package type, the runtime, and so on and so forth. So you have a bunch of default, but for instance, you can select to use ARM over x86. You can select a different memory size, a different timeout, if you want to use reserve concurrency, provision concurrency, and so on. Everything visually. That is handy because if it's, you're working with a colleague or inside the team and you want to understand how would look like your service, you can quickly put together a bunch of resources, prepare the file, and then you can deploy on your AWS account without any problem. Now, as you can see, there is here a resource configuration as being saved. Where is being saved? So we said before we have a template YAML. This template YAML is basically now filled with quite a lot of information. So we have our API gateway, we have our Lambda function, everything is configured for us. And this is like a CloudFormation template. So you don't have to, we know that CloudFormation can be sometimes nasty for developers. It's very verbose. You need to understand many things. But in this way, you can have an easy way to build that without any problem. Now, the cool thing is that the application composer can be helpful in another situation. Let me switch for a second in another project. So this one is another project that I have that basically is an API that I created my infrastructure with the CDK. That is Cloud Development Kit is another way that you can create your infrastructure as code, but instead of being based on configuration, so YAML and JSON, you can use your favorite programming language. So you have TypeScript, you have Java, you can use .NET, or you can use Python, whatever it is. And you can basically describe exactly the same thing, and this example is basically a craps game that you can find at a casino. I presented this at reInvent in Vegas a few months ago, and obviously the best team there is talking about gambling. The interesting part is if you have application composer and you are going to clone one of the repository of your colleagues just to understand how the infrastructure looks like, you don't have to go through all the code and infrastructure as code and trying to understand all the different bits. Every time that you work with CDK, you can do CDK synth that basically is understanding and preparing a CloudFormation template behind the scene. So when you're using CDK, we're not doing anything magic here. We are just transforming whatever language you are choosing for creating your infrastructure as code into CloudFormation. So here, as you can see, there is a CDK out folder that when I open creates a bunch of iteration that I have done. But the interesting part here is this stackname.template.json. So this one is basically the output of CDK into CloudFormation. And the cool thing that you can do, if you do right-click here, you can do Open with Infrastructure Composer. And now, let me close a few things. You have an idea of what this application does. Now, this is very simple. And Application Composer, unfortunately, at the moment, doesn't create CDK code in whatever language you want. It creates only CloudFormation. There were a lot of requests by customers to have also the possibility to generate CDK. And hopefully, one day, we will see that available. But this one is pretty cool, because if I'm the first time that I'm, let's say, taking a microservice, or I want to understand how the things are working, I can have a visual representation of what's what's happening, and at least I have a starting point more than digging across thousands of lines of code that is, let's say, quite boring to a certain extent. Also, I need to understand all the construct and understand how they are associated together. So those are two ideas on how you can use Application Composer. Now let's go back to our demo. So now we have this simple API. Let's see what created I selected Node.js in this case, so I'm going into the function. So I can specify the name of the function and the name of the folder of the function, and also how my function is structured. So by default, I have this index.js that is generated. And here, as you can see, I have a basic signature of a Lambda function. So I have like my handler that will be invoked every time that someone is triggering this function. But as you can see here in the return, I don't have anything. It will be just an empty result. So here we can start to use a bit of generative AI with Amazon Q. So you can add a comment to say, I want a response, return 200 response with hello Amsterdam. So if everything goes fine, now we have a new return that is this response here. So we have a new variable, we just use it, boom. So now we have at least something that is returned. We don't have to think about how the structure would look like and stuff like that. It's going to be done by, in this case, contextually by Amazon Q. So the interesting bit is now, OK, we have an API that was created like a simple drag and drop. We have a bunch of code that we can execute, so we can try out. You can do that through Application Composer if you want. So here there is this sync button that will synchronize with your AWS account that is set up through the AWS CLI. But I want to show you a different way to do that. So another approach is that you go into the template, right-click, and you can have like here an option that is saying sync SAM application. OK? So when you do that, it's starting at the top of the IDE, the Visual Studio Code, a bunch of interactive questions. So I want to specify the required parameters and save as default. Behind the scene, we said that it's using AWS SAM. So what SAM does usually is creating a TOML file that basically collects all the information that we are selecting right here. So in this case, for instance, I want to use EU West 1. That is where I usually deploy my application. I want to create a new stack name that is Devworld Amsterdam. I want to create a new S3 bucket managed by the CLI, and then I have a bunch of options here that are provided by, that are basically the same thing that you can do with the terminal, but without using the terminal because maybe you don't know how it works. One thing that I want to drag your attention is that watch, let's say, flag that is there. That is the one thing that we are going to see in a moment in action. So we are all happy. So now, should start to build a bunch of things. So as you can see now, my terminal started to deploy the application that we are seeing here. I think I saved this file. Yeah, I should save. OK, but in the meantime that we are waiting the deployment, there is another thing I want to show you. So during reInvent, we announced also another cool thing of Amazon Q. So Amazon Q is our code assistant that is integrated here. So we have a bunch of agents that are integrated here. So if you do /, you can see them all. So you can generate code. You can generate tests at the moment only for Python and Java, but you can those are basically agentic action that you can apply. You can review some code, but the interesting part for me is the documentation part. Very often we write a lot of code, but then no one knows what it's doing unless we create decent documentation. So in this case, we have a very basic things. But imagine for a second, if you have like a complete project and you ask to this agent to create a README file. So now it's basically thinking and starting to here we are, yes, on this demo init. And they start to check all the files that are available in the project. They are preparing, basically, summarizing the file and generating a README file for us with quite a lot of information. So now, in a few seconds, it will be ready. And it will show basically a very simple README file, but with all the information that are needed. Very often, you know, in Amazon, when we are creating an open source project just to show an example, whatever, we are requested we create a README file that is full-fledged with a bunch of information, like how I can install the resources, how can I build the resources, and all the other things. Because obviously, if someone is not familiar with how to work with AWS, you can do that, let's say, through the documentation. So now, the documentation is ready. So as you can see, we have a file. Let me save this file so I can show you for a second. I want it in demo init, readme, perfect. So open preview. So this is basically what is generated. And you have like a repository structure, user instruction, what you need to install, the installation part, quick start, and you have basically all the steps that are needed in order to run this example very quickly. I didn't have to think about, oh, hang on, I need to add this specific thing or whatever. It just created that for me, and then obviously I can instruct and change in the way that I need it. So it's pretty handy, this part. Now, we have, in the meantime, I was talking and generating the documentation. I also deployed my API there. So there are different ways that you can now invoke an API. But I want to show you one thing that very often is ignored, by my opinion, wrongly so, because the AWS Toolkit has a couple of capabilities that I really like when I'm building stuff. So here, when I configure AWS Toolkit that is available, completely free, so you just download on the marketplace in Visual Studio Code, you can go into your Lambda function in the region that you selected for doing that, for deploying your application. I think it's called Devworld Amsterdam. Here we are. So as you can see here, I basically see what I have deployed in that account, in that region, in the cloud. So I just downloaded all the information needed for then interacting with this stuff. So if I click this button that is the play, I can remotely from my IDE invoke a function without even going or retrieving the URL or understanding going to the console, AWS console, and so on. There is a feature of the AWS console that I really like. So you can, let's say, create a JSON file that then it will be stored and is available across for everyone inside the team across all my Lambda functions. So potentially I can go in the console, create a test file that I use, and say, okay, this is the JSON, the payload that I want to use for testing this Lambda function. So I can even, if I have some of them, I can fetch them remotely and use that specific payload directly in my IDE. So from here, I can go here and select, in this Dropbox, you are going to have, drop-down, you are going to have all the different events that were created by you or by someone else in the team. But you can also use a local file if you prefer, or you can use inline. Now, one problem that you have when you're working with Lambda functions that can be triggered by anything. It could be Kinesis, it could be SNS, it could be SQS, or whatever. And therefore, in order to understand how the payload looks like, if you go here and select inline, you can select all the different payloads that are available for triggering a Lambda function. In our case, we are going to use an hello world because we don't need anything. Those are exactly the same that you have for when you go in the console. Very often, when you go in the console, there are people that are copying and paste the JSON inside their IDE and create local files. You don't have to. You have everything available here. So if now I call this function, I have a status called hello Amsterdam, right? Very simple, all nice. So we have, so far what we have done, we built from scratch an API. We created a bit of code for doing certain things that is just outputting something. Let's assume that you want to change things. Now, if you remember, before I drag your attention into the watch flag that was available inside the drop-down and the wizard that we were looking at. So now, if for a second, let's assume that we are going to change one thing here. So instead of hello Amsterdam, say hello dev world. Now let me do this. So it's a bit juggling between tabs. It's quite funny. So take a look here. It's not interactive, this part. I cannot write anything there because it's still watching and waiting for something. So if I save now the file, what's happening is that it's building my Lambda function with the new code, and it's finished to sync my Lambda function using the API, not using CloudFormation. So we are basically drifting away from passing every time through CloudFormation, straight leveraging the API of the Lambda control plane in order to deploy our new code. So now, if I invoke again this Lambda function using the toolkit here, and do remote invoke, as you can see, if I'm capable to increase the size of this window, here we are, we have hello Devworld. It didn't pass through CloudFormation at all. It literally update through the API the specific element, and off you go. Now, the cool thing is if I now change something on the infrastructure, and I will change, I don't know, the runtime from node 22 to node 20, for instance, it will pass through CloudFormation. So only for things related to infrastructure, it will pass through CloudFormation. Now, if you think now the change rate that you have in your applications is more likely that they are going to mess up with the infrastructure at the beginning of the project when you start, because you want to set up the things. At the beginning, you have maybe the Lambda function, then you say, OK, I need SQS, so let me add SQS, and stuff like that. But when you have all the infrastructure stable, this will accelerate your debugging in the cloud, because you are debugging in the cloud. That is one thing that we highly recommend, because in reality, when you are doing local testing, you can use unit testing very easily, and you can test, let's say, how the application works. But no one is testing for, I don't know, the IAM permissions. Do you have the permission to run a specific code, to call a specific resource? What about latency? And those kind of things in distributed system matters, because if you don't look into this part, then you are missing a big part of your application. Now, as usual, when you are in a situation like that, we've just invoked a couple of times the Lambda function, and we are happy with that. But one thing as a developer you want to have, more often than not, is also, let me call a couple of times, looking at logs. And the majority of the time, unfortunately, we were used to go, and I still see customers doing that, that they are going to the console, and then from the console, they go to CloudWatch, select the log group, and blah, 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 blah. But also here, the toolkit comes very handy here. So I can select the region. So in this case, it's fine where I am. And I can say that is, how I call it, Devworld Amsterdam. So it's fetching the log groups directly from my CloudWatch. So I don't have to do anything. I don't have to search that. I have like my search box directly in my IDE. I can select a period of time. So let's assume the last 15 minutes, for argument's sake. I want to search a specific path, and I'm looking for an error, maybe a 500 error, whatever. I can. In this case, I don't need to. And now, I have my logs available in my IDE with the tracing ID and whatever you set up for your Lambda function without you doing anything, so you know exactly the information you need. So if you start to add, I don't know, logs, metrics, and anything else, it will be available there without any problem. That's extremely handy because it doesn't only help you when you have, let's say, old stuff that are happening. So now let's call a couple of other times my Lambda function. And then I know that it's very small, but here there is a load newer events. So in few seconds, we should see, the moment that they arrive into CloudWatch, we should see them straight there. That's another thing that is extremely handy, because as a developer, I want to have all this information. Obviously, it takes longer than needed. I want to have all the information available here. And I think this one is another cool thing that you should be aware of. Because as you have seen now, we created something from scratch, we deploy something from scratch, we update some code, we can update ideally also some infrastructure, but we don't have time. We can retrieve logs. What else can we do? There are a couple of other things I want to show you. So let me go back for a second into the other application. So there is a library that is fully open source that is called Power Tools. So very often, you know, there are customers saying, oh, yeah, we have multiple teams working with Lambda, but we struggle to have a consistency in logs, metrics, and so on. So back in the days, I was working for a company called The Zone, and there we created this idea of Power Tools. Power Tools basically was an open source library that enables our developers to quickly have a standardized way for building logs, metrics, etc. Now, AWS was, specifically one person in AWS really felt in love with this idea, so he started to create Power Tools owned by AWS as open source project in multiple languages. So you have in Java, C#, you have in TypeScript, you have in Python, and they not only now taking care only about the logs, metrics, etc., with all the best practices built in, so you don't have blocking event or metrics that are sending to CloudWatch while you are executing your Lambda code. We are going to derive that through JSON, through structured JSON that will fill up your logs as well as your metrics. But also, you have a bunch of patterns that are very common. Right? For instance, if you think about idempotency, many of the services when you are using an event-driven architecture are not exactly once delivery. So you can have multiple times receiving the same event or the same message, and it has to be processed. Therefore, a pattern to solve this problem is idempotency, where you are checking if you already have seen that ID. So usually what you do is basically creating a table, a dynamo table where you check the ID, you store the ID, the event that you processed, and then you check if in reality this specific ID already passed through something. And if it does and is already available, you just drop the message. That is extremely common in many of the, let's say, event-driven architecture that I build with customers. Therefore, in that case, you don't have to build all the things that I described. You just implement with Power Tools, and you're good to go. There is another tool that that I think is quite interesting that I want to show you, that I have here. Let me see if I can show you. Yeah. So this is called Power Tuning. And the problem that we try to solve here is another open source solution. You can deploy in your AWS account, and basically what it deploys is a step function that enables you to test your code, exactly your code, with different memory size. And the output of that is the generation of this diagram that enables you to understand how much will potentially cost your Lambda function and how fast will execute in a certain specific setting. So on, let me see, on the Y side, we have how fast the Lambda function executes. So for instance, if I set, that is a common misconception in Lambda, 128 megabyte, and we think that we pay less because the memory is lower, unfortunately, it's not the case. It depends from your code. So as you can see, that takes 6 seconds for it to execute. But the same code to 1 gig, that is more or less here, it's way faster. So it's less than half a second, roughly. Now, if you see in the blue line is the cost. How much is going to cost? If you set to 128, it performs worse than 1 gig, and it costs more. So with this diagram, you don't have to guesstimate anymore the size of your Lambda function. You just take this solution that is available in Terraform, CDK, etc. You deploy, and off you go. You can know exactly how long will take your Lambda function with different configuration without saying, let me try 128, sorry, or 256, whatever. That is great, and you can find that open source at this link. You can find, even if you're using Terraform, we created, last year I created a working group to update Power Tuning in order to have the latest and greatest. So now we have an official Terraform module available for Power Tuning in the Terraform repository. That is absolutely great. So that's all that I want to share with you. I hope that you take away something or something useful, some hints, some ideas. I will stick around for another couple of hours before taking my flight. So thank you very much for coming, and enjoy the rest of the conference.